So we're going to use some trig identities to simplify this to a single trig function. So first of all, I'm going to rewrite secant as 1 over cosine. And then sine x times tangent x. Tangent is sine over cosine. So they have a common denominator, so you can combine them to be 1 minus sine squared over cosine. And then from the Pythagorean identities, sine squared plus cosine squared equals 1, which means 1 minus sine squared is cosine squared. And then cosine squared divided by cosine is just regular cosine. Do the same thing with this one. So that's cosine x plus tangent, which is sine over cosine, times sine. And now they do not have a common denominator, so we will make them have a common denominator by multiplying by cosine and cosine, so that becomes squared. So we get cosine squared plus sine squared all over cosine, which is 1 over cosine, because cosine squared plus sine squared equals 1. And 1 over cosine is secant. So we're going to follow the same idea here. Secant squared minus 1, though, that comes from 1 plus tangent squared equals secant squared. So if we rearrange that, that means secant squared minus 1 would equal tangent squared. So we can replace that denominator with tangent squared. Then the tangent on top cancels one of the tangents in the denominator, so that becomes sine over tangent. Tangent is sine over cosine, so that's sine over cosine. So we will flip that to the reciprocal. Multiply by cosine x over sine x. So the signs cancel, and we're left with cosine x. So for this one, if you don't see anywhere to start, just start with changing everything to be sines and cosines. I don't see any Pythagorean identities or anything, so secant is 1 over cosine minus cosine over tangent, which is sine over cosine. Now you can see that there's a lot of denominators of cosine, so let's multiply every term by cosine. So that's 1 minus cosine squared over sine. From the Pythagorean identity, sine squared plus cosine squared equals 1. That means that 1 minus cosine squared is sine squared divided by sine, which is just sine. Verifying identities is pretty similar. It's just now we know what we're working towards. So this time we're trying to get it to equal tangent times secant. So just looking at these two, I see that they both have sine. So to see what happens if you factor out a sine. So factor it out, then we unveiled a Pythagorean identity. 1 plus tangent squared is secant squared. Secant squared is 1 over cosine squared. So if we kind of rearrange that a little bit, we could say sine x over cosine times 1 over cosine. And sine over cosine is tangent. And 1 over cosine is secant. Done, done, done. So trying to get tangent x, since the right side of this equation is more complicated, that's the one I would choose to work with a little bit. So 1 plus tangent squared that is secant squared. 1 plus cotangent squared, that is cosecant squared from the Pythagorean identities. And now I would change all these just be sines and cosines. So cotangent is cosine over sine. Secant is 1 over cosine. So secant squared is 1 over cosine squared. And then cosecant is 1 over sine. So do the reciprocal of the denominator. So sine squared comes up top. So that's now cosine times sine squared on top in the numerator. The denominator is sine times cosine squared. Now you can cancel. One of the signs in top cancels with the sign in the denominator. The cosine in the numerator cancels one of those signs. So that is sine over cosine, which is tangent. All right, so this time I'm going to start on the left side just because it has the minus. I always prefer to start with those. Cosecant is 1 over sine minus sine. Then since it's two terms, the easy thing to do is get a common denominator so you can combine them. So multiply this one by sine x, so it becomes sine squared over sine. So now it's 1 minus sine squared over sine. 1 minus sine squared from the Pythagorean identity. That'll be cosine squared over sine. And then, just to make it obvious, if you separate those cosines, now you have a cosine by itself. And then cosine over sine is cotangent. For this, the left side's a little bit more complicated, so I'll start with that. So tangent plus cosine over sine. Since there are two terms in the numerator and only one in the denominator, that can be split. So you can write that as kind of undoing once you get a common denominator. So it'll be tangent over sine and then cosine over sine, because normally you would combine those and just write them with a single denominator. So we're undoing that. Tangent is sine over cosine, all over sine. Cosine over sine, we can just change that to be cotangent. So we're already halfway where we need to be. We just need to show that this fraction reduces to secant. So that'd be sine over sine is the same thing as sine over cosine times sine. And the sines cancel, so that's 1 over cosine. One over cosine is secant. So we're done.